Next chapter, chapter 6, is multiple linear regression. Here we're going to be looking at interval target, and we'll also look at model building. Okay. In previous chapter, in chapter 5, we already looked at how to develop a regression model and how to evaluate performance measures. And we did lift charts and stuff like that. So we'll start with reviewing how to develop regression model, a simple one, and then we will go further in model building. Okay, so first let's set up our default path to the folder. Okay, and then let's look at the libraries that we want. Okay, so let's go ahead and run these libraries. Forecast for accuracy, Caret for regression, and Leaps is a library that we want for model building, stepwise regression and so on. And then Grid Extra for plotting charts in a grid form. All right, now let's load the data. So we're going to use the same data as in chapter 5, which is Toyota Corolla data. Toyota Corolla CSV. Okay, so run that. So we have the car.df. Your textbook uses only the first 1000 rows. I really don't understand why you have to restrict yourself to 1000 rows. So we'll just skip that. We will use all the rows. Okay, and the data set contains a lot of unnecessary variables. So like model name and I don't know, manufacturer's guarantee and onboard computer, whatever. So we're going to select a subset of these variables. But before that, we have to do something, and that is we're going to be using doors as one of the predictors. Okay, and that is number of doors. What is it? So that one is a categorical variable. So let's go ahead and convert that to a factor. So car.df doors is car.df. Well, you have to say as factor, right? car.df doors. Okay, so that will convert it into factor. So let's look at the structure of car.df. Okay, so we have lots of integer variables, and then doors is factor, and then we have color. We can change color also to factor. I think color is I'm not sure whether we're going to be using color. Let's see. Uh, okay, so we're not going to be using color, so let's just leave that aside. So we're going to select only some variables. So let's call that selected var. So, and we have to give that as a list. So 3 is the price, and then we're going to select 4, 7, 8, 9, 10, 12, 13, 14, 17, and 18. Okay. And then let's set up a new data frame called car.select.df. So that would be that all the way, all the rows and selected one. Okay. Okay. Now we'll run these 2 lines of code. Okay. So we have selected 11 variables. Okay. Of which the first one is the price. That's our target. Price is a target, and there are 10 other variables. Okay, so now let's partition the data into train and valid. So we start with train dot index. Okay, and we want to sample we want to sample from a sequence of numbers starting from 1 through the number of rows. So here we can say n row car select dot df, which will be the same as car.df, and we have let's make sure that the parentheses are okay. All right, so now we have to specify how many we want. Let's say we want 60%, right? 60% of n row car.select.df. Okay, so let's make sure that this works. So now we have train.index. So then we can set up train df is car.select.df, the train index, right, and all the columns. And valid.df will be car.select.df, okay, minus train.index and all the columns. Okay, so now we run these two. We already have the train index. Okay, so now we have the partitions. All right. Okay, so now let's run the regression like what we did, like how we did in chapter 5. Okay, and so we'll call the regression, we'll capture the regression results in car.lm linear model. So we run lm, okay, and then give the formula. We want price to be regressed against all the variables, and then we give data equal to train dot df. Okay, so we run that and we have the results stored right there. Okay, so now we can do summary. of car.lm. Okay, and we have the results here. But there are a lot of scientific notation numbers, so we can brute force uh, scientific numbers into regular numbers by setting options, and we set a penalty for scientific notation. So if you set a very, very high penalty, then um, you'll avoid scientific notation altogether. Okay, so then you see, so you have regular numbers everywhere. Okay, and to evaluate the performance, okay, so we need the actual value and the fitted value. The actual value is already there in train .df and valid.df, and we have to get the fitted values or predicted values. So car.pred.tr, so that's from the training set, and the regression results already has that, so car.lm, and that would be fitted values. Okay. And then for the predicted values for validate set, you have to run the predict function, and predict function you specify where the model information is saved, so that's there, and then the new data is valid.df. Okay, so when you run these two lines of code, we get the fitted data. Okay, and then we can find the accuracies and then put them in a data frame. So ACCTR is accuracy. Okay, and we have to provide two parameters here. One is the predicted value and then the actual value, train.df price. And then we have to find the accuracy for the validate data, so car.pred.vl and then valid.df price. Okay, and then we will put them in, we'll transpose these so it'll be in column, and put them in a data frame. So ACC1DF is data frame, right? So the first one is, okay, we have to transpose T of ACCTR and then T of ACCVL. Okay, so we have, and then let's print ACC1 DF. So we'll run these 4 lines of code, and there it is. Okay, and now because we have a very high penalty for scientific notation, you see it's printing all of them in regular numbers, and there are way too many decimal places. So let's go ahead and round to say 4 decimal places, and the result comes up with 4 decimal places. We have to just do one more thing, so we have to give proper names for this. So let's say names ACC1DF, see, and this is just regular linear model. So let's say train.lm and valid.lm. So let's run that, and so we have the names changed.